Mario, November 20th, Thursday, 2025. I just did a short video of this particular assembly here. This is an elaborate setup here. I just did this in 3D printed form. It is something that I've done in the past. When I embarked on doing my helicopters back in the day, before I arrived at a very simple fixed pitch helicopter such as this Bumblebee that I used to sell back in the early 2000s. I had already done a bunch of contraptions, mechanical contraptions, all sorts of contraptions to study the geometry that would yield a fluid control to a helicopter. But I was also, since I was trying to manufacture something inexpensive and very simple, I was also looking for something simplistic, and this is what I arrived at. This pitches, so it's independent of that movement right there. It's very simply controlled via two links, via an anti-rotation arm to the swash plate. Now you'll notice that my swash plates are, most of my swash plates on these fixed pitch helicopters have let's see, where's that one? This one right here. It shows it a little bit better. It has this type of arms right here, and that's so that I can effect the control via mixing of two servos. So I put two servos here, and they both operate the pitch, and they both operate the roll in differential form. So it requires mixing. When you have that with radios such as even this one right there, you have the mix feature in the radio. So that's how I control my helicopters. I've been controlling them. On some I did some very early ones. I used to do the conventional way with the pitch, one servo, roll the other servo. Very simple, almost like a airplane nomenclature there for one servo for pitch, one servo for roll, or one servo for the elevator and one servo for the rudder. So in this particular case, you can see here, I just printed this a couple of nights ago. I designed all these parts. I had to basically look at some of my older setups that I used to do, and you can see here these are all sorts of rotors that I used to experiment with back in the day, and this is just a small portion. I mean, I got boxes and boxes of these things already on helicopters that it would require many more videos and to talk about to show. But just to give you an idea, I did some of these in aluminum. I did some in fiberglass, very simple. These are some of the more simpler ones, but I did do some more elaborate ones, such as this configuration here, for pitch, for a collected pitch helicopter. And this is at the time that I was doing the Bumblebee. It says this is part of the pitch control of our tail, mechanical tail rotor. It's a little dusty here because I haven't touched this in years. And so one of these days I'll just have to come back to this area here in my shop and clean this up. But I just give you an idea, some of the stuff, the rotors that I used to do. In addition to, I got boxes and boxes. You can see all sorts of swash plates, rotor heads that I also was doing back at the time when I developed, the very first the Robin 280 micro helicopter, aluminum swash plates, all kinds of things here. These are for the these I did in a CNC machine. These for the housefly, and some other ones in fiberglass that used. Some of these use injection molded parts. Some of these use beads, for the ball links, and I explained that in some other video. These are not solid balls; they're beads for jewelry making. They're called spacer beads. So I was employing some of those right embedded on this fiberglass little tiny arms that are about 1.5 millimeters in width. Those little arms, and I just stuck the beads over that with CA glue, and it makes for a very lightweight swash plate. And so I was doing a lot of this stuff just to prove my point here. Very, very early on in the game, and so this is nothing new. And I wanted to do that. I wanted to show that those other parts, because when I do this, and I don't talk about the other stuff that I've done, people think that I'm just inventing some of these things. This is not. This is a concussion out of many ideas here. but in a very simplistic form. This right here is to establish a little more fluidity on the rotor head as the flybar pitches in for control for dynamic rotor control, directional control. And so that's the purpose of these links. It's not a direct connection, to the rotor head, but it's sort of an offset here, and that's just to allow a little more fluidity in the control system of the rotor head. It allows for a little more stable rotor, and also it allows for more stable rotor. I'm not even showing specific. There are other ways to do this with angles here, angling the offsetting the flybar. Right now the flybar is at 90 degrees with the rotor head with the blades, but there are some other systems that you can employ to give it additional stability and control, fluidity by skewing the flybar. I don't like those skewed angles. The SRB Cork has that type of rotor. If you've seen that rotor, it has the flybar. It's not at 90 degrees with the rotor head. It's offset. And so there's a number of ways to do this, but this is something that I've been contemplating employing on some of these bumblebees right here in lieu of that more simplistic rotor here. There's nothing wrong with the rotor here. I'm not doing this to replace that totally. I'm just doing this to test this in a 3D printed form. I've done this with metal parts in the past, and so I decided to do it in 3D form and see how these parts hold up. So basically, that's the purpose of this contraption here.